All right, everybody, good stuff. Welcome. So, I am sorry if you were intending to come to this talk earlier. There has been a very bad miscommunication or misunderstanding on my part, so I apologize for being late. Second of all, don't look that way. Don't look outside. I don't know if you've seen what's out there. Don't look at it. You'll be distracted, as I am right now. Wow. How would you, I don't even understand how you would hold a conference in that. It looks so, it's like paradise. Anyway, can you see the screen? Is all that beautiful light from outside making it hard to see what's on the screen? You can see the text? Oh, good. It's fine. It's not like I want to close the beautiful view. Okay, so we don't have a lot of time, my friends. We don't have a lot of time. I think we've got about an hour, which is 60 minutes, and that's about it. That's about it. So as a result, whenever I do a presentation, I always start my presentations with this very same slide. It's a very simple slide. It says where you can find the code that we're going to follow along with today, where you can find the code that we're going to look at today, for your own reference, your own edification for later on, not now, surely not now, but later. And of course, there's my coordinates. So should you have questions, comments, feedback, whatever, don't hesitate to reach out to me. I am, as always, very happy to engage, happy to answer questions, etc. So if you should take one photo of one slide in this session, this is probably the one you're going to want, because ineluctably you will have questions, and I'm here to answer them. Maybe not now, but later, asynchronously. I'm at your service, okay? So don't hesitate to reach out. A little bit about me. My name is Josh Long. I'm a Spring developer advocate on the Spring team, and I have been since 2010. I am happy to be here and happy to be in all sorts of different places every year. Talk to, 500 to 600,000 miles of airline travel every year, going around to different countries all around the planet, talking to people about how to build better things with Spring. And as a consequence of that, some weird things have happened. They made a toy out of me in China, for example. There's China. I have training videos. These are on Safari. These are sort of deep dive, 5 hour, 6 hour, 7 hour master classes for different kinds of topics. The best ones invariably are the ones with somebody else. So me and somebody else. Watch those first, then you'll have a better sense of what's possible. I wrote a book in 2017 called Cloud Native Java, which is all about how to build applications that survive and thrive in the cloud in terms of Spring Boot, Spring Cloud, and of course Cloud Foundry. And this book is something about which I'm very proud. It's something on which my co-author Kenny Bastani and I worked long and hard, and we thought we'd get the book done pretty quickly. We thought, given our sort of privileged position within the community, we'd be able to knock it out in about 6 months. As it happens, it took a little longer than we expected. We were a little late. Me late? Imagine, right? Like, no, it was a little late, and then again, not a big deal. Okay, just a tiny delay, not a big delay at all. We were thinking 6 months, and it did, in point of fact, just take a little bit longer than 6 months. It was just a tiny. It was like 2 years. Okay, it was like 2 years before we got that stupid book done. But that's okay. That's okay. There's a good reason, as always, for that delay. The essence of our delay was that we spent that extra year and a half ruminating, pondering, debating, deliberating the animal on the cover. Now, anybody who knows anything about O'Reilly books knows that it doesn't all that much matter what's in the book proper. Nobody cares. Have you ever read one of these books cover to cover? Of course not. See, I didn't see a single hand raised. That's because the animal's what makes or breaks it. If you look at all the Amazon comments on Amazon.com for these books, it's all about the animal. It really matters. So we eventually settled upon a blue-eared kingfisher. This is a bird with blue ears. It's a bird with blue ears that is indigenous, or as we'd say in English, native to the Indonesian Java Islands. It's a bird that is native to the Indonesian Java Islands, and birds, they fly, yes, through the clouds, So it's a bird that is native to Java that flies through the clouds. It's a cloud native Java bird. Never mind, it'll come. I have a podcast every Friday. It's me talking to somebody smarter than I am invariably, and about something in the Spring or ambient Java and JVM ecosystems. And so some of the people at this very conference have been guests on that podcast, for example. I have a roundup every Tuesday I do called This Week in Spring. It's just me it's just a roundup of all the latest and greatest news and videos and content that's fit to reprint here. And of course, every Wednesday there's a screencast I do on YouTube called Spring Tips. So it's just me at a keyboard, 30 minutes usually, 35, 45, 55, whatever minutes, introducing one topic in depth. And of course, I'm working on a new book called Reactive Spring. Now, today, my friends, we're going to talk about a number of different things, and we're going to talk about all those things in the context of testing. And it's important to motivate why we care about testing. I don't think in 2019 that I really need to motivate testing itself, right? I think we can all agree that having some sort of formal verification of your software is a valuable thing. What we care about is test-driven development, right? This idea that I'm going to proceed step by step, writing my code, and as I move through my code base, I am going to do the testing first. And there's a number of reasons why this is a valuable idea, right? There's a number of important reasons for this move. Now, by the way, am I wrong in presuming that you're all testing? I want to make sure. Who's doing testing? That was facetious. Everybody should have been raising their hand. So that's awkward. That's not great. We need to do better, friends. But test-driven development, I can kind of understand why some of you may not be doing testing. Actually, that's a good point. I should mention that. Test-driven development solves some of the issues with testing. That is to say, testing feels a bit like a chore, doesn't it? It's something that if you do it after you've written the code, you're sort of doing something again. It doesn't feel very satisfying. Think about how most of us work. We write something, we get the code working, and finally it works and we get that endorphin hit, right? The same endorphin hit, the same sort of euphoric moment of zen that video game players get, joggers, people who jog, people who run, right? They get that upon completion of something. By the way, anybody who's a jogger and they say they like to jog, they're lying to you. They don't like to jog. They like to get done with jogging, right? They like to cross the finish line. That's what feels so good. The jog itself it's literally the definition of pain. You know, it's unnecessary movement for prolonged periods of time. No. What they like is they like getting across the finish line, and they like knowing that they're close to getting across the finish line, right? There's that euphoria associated with crossing a horizon, a perceptible and imminent horizon. The same is true for video game players, right? A good video game, the reason it's so addictive is that you constantly feel like you're close to an imminent and perceptible horizon. You feel like if you just keep going one more minute, you'll get there, right? And you're in that moment of zen, oh yeah, good stuff. You feel like you're in that moment of zen, right? You've got that, like, you're in the zone. Isn't that what we say when we do code? You're in the zone. When you write code and it's going well, you feel like you're moving quickly, and the next thing you know, what happens? You sit down at 9 o'clock in the morning, and next thing you know, it's 9 o'clock at night. You ever have that happen? Right? I'm sure most of us have had that sense, right? And I feel like the older we get, the more corporate America or corporate Canada perhaps wants to distract us with other things. When you're young, they just want you to write code. And that, I feel, is when I was most happy. Unencumbered, unbothered by all these other concerns, these ambient things related to the work that I do that isn't the work that I do, right? Same for video games. Same for jogging. You have this sense of being in the zone. It's very satisfying. And when you get to the finish line, you get that endorphin hit. You get that sense of, I did it, I succeeded, I won, whatever, right? That sense of euphoria it's what keeps us moving, right? It's what motivates us to keep trying, to keep going. So imagine you write your code, and now it works on your machine, but you haven't written the tests. Now you have to go back and write the tests. Well, that feels a bit like a chore, doesn't it? You're not actually. There's no fun in that. You've already made it work. Now you're just proving that you made it work. That's not fun. It's a bit like documentation. Sure, somebody's got to do it, but there's no fun in it, right? Nobody wants to get a documentation ticket or something. And so this is why you have whole philosophies around, make it work first and then maybe write documentation, right? People say, oh, well, the code should document itself. Nah, that's not always true. It's just that you're lazy. You don't want to write the documentation, right? So we have this problem where we're trying to write code and we're sort of burdened by these extra concerns. With test-driven development, we flip it around. You get the endorphin hit as soon as the test is green, right? You write the test first. As soon as it's green, the feature is delivered and the test is done, right? They happen at the same time. So you never get dropped out of flow, out of that zone that you're trying to maintain, right? This is valuable. By the way, that sense of euphoria, that sense of motivation, right, that I was just describing, that sense of being in the zone, it's the same basic chemical process in the brain as is induced by cocaine users, right? Cocaine addicts. So write tests, not drugs, right? Don't do drugs. That's a PSA for you there. I think that would have been big in the 80s, right? So we have to stay in the zone. We want to keep writing our tests. We want to see things get better and better perceptibly. And there's a couple ways to write tests, right? There's we can do test-driven development. And like I said, I think the fact that it makes it fun, the fact that you get to stay in the zone, that is really the biggest feature for me. But it also has some other benefits because there's some discipline associated with that. If you know that you are writing tests first and you know that everybody else is writing tests first, well, there's an interesting side effect to that, isn't there? That means that everybody in the room is no more than a few command Z's away from having shippable code or control Z's, right? You can roll back a few keystrokes and hopefully your build is green again, and then you can deploy. If you write tests first, if you have confidence that everything is tested, then you can do interesting things there. If it's less than 100% tested, why MMV, right? So we've decided to do test-driven development. The question then becomes, well, how? Where do I start? Do I start with the smallest component first, and then work my way up to the larger sort of component, the services and the web tier and the APIs and the microservices and so on? Or do I work my way in, or down, I suppose, going from let's say the user interface as a common relatable anchor? Do I start from the user interface and work to the components, work my way down to the micro components that support that thing? Or do I do it the other way around, right? It's a question a lot of people struggle with, and there's good reasons to do both, right? If you are trying to, if you have large teams, lots of different teams, right? If you're in an organization with lots of different teams, hopefully you've sort of appreciated the given wisdom that moving to microservices can be valuable. So if you have a lot of different teams, a lot of small teams, because it allows them to focus on one little thing, one small, independent, deployable thing. This is autonomy that we get, right? We get autonomy by moving to microservices. It allows small teams to focus on one thing that they can deliver. When you move to microservices, when you move to that architecture, the user interface is no longer a user interface per se, it's an API. It's an HTTP endpoint, right? And so the question is, do I start with the HTTP endpoint and then work down or work up? If you're doing team-based development, which one is going to support different teams moving autonomously better? Right? Like if you start at the API level, then that's the integration boundary for different teams. So that means that you have to spend a lot of time up front formalizing the boundary between those different APIs. That means that you end up spending less time doing work, right? You're not actually delivering software. So a lot of teams say, oh, well, okay, if we're doing microservices, then we'll start small and work our way up, and we'll defer the integration, which is potentially the most risky part, to later. If you feel like the integration is not going to be a big deal, then you can delay that until later. And the benefit of that is that you can get the business logic of actually talking to the database and building the HTTP tier and getting all that stuff done independent of each other. You can all move autonomously towards that common goal. And then when you finally get there, you integrate. But if you feel like the integration is going to be super risky, and you want to figure out that integration right now, before you all start moving autonomously, then maybe you do the other way around. Maybe you start from the API and then work your way down. Right? For my purposes, for our purposes, I suppose, today we're going to start with the small stuff, and we're going to work our way up. We're going to go up because it allows me to introduce things in turn as a matter of edification, right? As a matter of teaching. So that's really why I'm going to go that way. But your mileage may vary. It's up to you. It's entirely a matter of taste and preference, and it's dictated by, among other things, those constraints I just articulated. Now, in order to demonstrate all these concepts, we're going to go to my second favorite place on the internet. Obviously, my second favorite place on the internet after production. I hear feedback. Anyway, we're going to go to my second favorite place on the internet after production. My first favorite place on the internet is production, of course. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather's amazing. It's the happiest place on earth. It's better than Disneyland. But if you have not been to production, you can begin your journey here at start.spring.io. If you need inspiration in the early morning before a cup of tea or coffee, start.spring.io. If your children are restless and they cannot sleep, start.spring.io. And if you suffer from indigestion after a long night of alcohol abuse and WebSphere, start.spring.io. So we're going to build a brand new application today. We're going to use Spring Boot 2.20 M6 because, hashtag YOLO. We're going to build a new application called a producer. And we're going to, let me see, I got to clear up my downloads directory, make sure there's nothing here to burden us. Okay, we're going to create a new application called a producer. We're going to use the reactive web support in Spring. We're going to use Lombok. Lombok's a compile time annotation processor that makes it just a bit more pleasant to work with Java. It's not unpleasant, is it? But it's just not as pleasant as perhaps some of the other languages invented in the last 25 years, right? So Lombok, that's going to be a nice choice. We're going to bring in reactive MongoDB, okay? I've got a reactive MongoDB, lets me talk asynchronously to my MongoDB database. And we're going to bring in the verifier, the Spring Cloud Contract verifier. We're going to explore what that is in just a moment. Before we move on, though, we have a few choices. We have a few choices that we need to sort of make before we accept the defaults. We need to specify the choice of packaging. People get confused by this. They don't know when and where to choose which option. So let me do my level-headed best here now to explain. If by some freak fluke of physics, some terrible tragedy of time-space, you find yourself somehow transported to the distant, distant past, far, 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 far beyond modern help, then choose .war. But if you're here with me in 2019, then choose .jar. We also have the choice of Java, right? You have the choice of Java version. Of these options, only one really is acceptable. One is no longer acceptable. Two of them are no longer acceptable. One is acceptable. We are supposed to be using the latest and greatest version of Java. So you have the choice between 8, 11, and 12. Well, keep in mind, Java 13 was just released a few days ago. In a few days, this website, I expect, will be updated to reflect that fact, to support Java 13. Were I giving this presentation to you just a few days ago, I would have said that there are two acceptable choices, Java 12 and Java 11. Java 12 is the current Java release. It's the one you should be using. That's the good answer. Well, actually, Java 13, but Java 12 is fine for the moment. Java 11 is the long-term supported edition. That's an acceptable answer if you want to park your applications at a stable sort of revision that will be maintained for a few years. I don't particularly approve of that approach, but sure, it's better than nothing. Java 8 is not acceptable in any context, ever. It's the wrong choice, not just technically, but also morally. Do you want to confront your children with what you've done at work today? Do you want to explain to them you're still using Java 8? Is that a discussion you're prepared to have? I think not. No. Use Java 12 at the least, probably even Java 13. Heck, I'm going to try moving to Java 13 just to see if it can work, because YOLO. Certainly, when I say you should use Java 13, I've got an early version of it that isn't on SDK Man. I don't have the final version yet. So there's OpenJDK 13. Might work. Okay. So I've got my dependencies. We're going to hit generate, and yeah, question, comment, feedback.
You want 2.20 M6?
Absolutely. No. Well, it's fine. Okay. Thanks. All right. So I'm going to open this up in my IDE. It doesn't matter what IDE you use, so long as it supports, well, in this case, Java 12. I'm going to use IntelliJ. I'm just curious, how many of you are using IntelliJ? Good stuff. How about Eclipse? Good stuff. What about NetBeans? Good stuff. Right on. See? All of these things support what we're trying to do. We need to support Maven or Gradle and the latest and greatest version of the JVM, in this case, Java 12. All of those do, right? Java 13 might be a little more iffy. NetBeans, I'm sure, already has support for it. I'll bet you IntelliJ does. I don't know about Eclipse. I'm sure it probably does as well. So, okay, now we're going to build a producer application. And when I say that, we're going to build an application that can you see that font in the back? Who can't see that? Raise your hand, because I want to make sure it's all legible. Okay, so we're going to build a new application. Here's the public static void main entry point into the application. We could start here, certainly, but I'm going to instead move to the tests. And we're given a stub of a test, or given a default test whenever you generate a brand new Spring Boot project. By the way, did you notice that we have a dark mode for the initializer? Right? I'm not sure if you appreciate that. That's still the initializer I'm using. And did you know we have a text interface? So there's a menu of options, and you go down here and you can see there's curl invocations that you can use as a template if you want to generate a project using Java 11, for example. Anyway, moving on. We have a brand new project. It's been generated using JUnit 5, and I like JUnit 5, and we should probably be using it. But just to make sure that you understand that this is equally applicable to JUnit 4, we're going to revert back to JUnit 4. And that means I need to delete this test, or at least change it. And that's fine, because I wasn't going to leave that there anyway. Because this test is actually pretty terrible, at least for what we're trying to do. What we want to do is build an application and write tests for every little component. So what's the first thing we're going to do? Whenever I write an API, I think of the entity, or rather, I think of the object, the domain, right? So let's think of that first. I'm going to create a test for the reservation entity, or the reservation object that we're gonna have. So I'm going to create a test for that, and it's just going to have it's just a very simple test. It's going to be public void create. All right, look at that. I'm going to say reservation R. And you can see we've already got a problem, right? We're starting to do test-driven development, and we've already got a problem. The IDE is saying that this type, which is red in my IDE, if you can't, I'm sorry for my colorblind friends, it's red, and the IDE is signaling to me that this type doesn't exist on the class path. And so I need to create that. I can't get very far in Java without a type. And so I create class, okay? I got that entity. And I want to prove that if I pass in an ID and a name, let's say Jane, that it'll create a valid constructor. So I have to go back. And by the way, you can see I'm in this kind of tight loop, aren't I? I write code in the test, and then I go back to the production code. I go back to the production code, and I go back to the test. I only write a few lines or a few characters, so long, just enough to get it to compile, which is sort of like getting the test to pass. And if it's compiling, then I run the test. And if the test is green, then I write more test, and then the test is red, and then I write more production code. And I constantly am in this cycle, right, of going back and forth. So a lot of people, when they do test-driven development, they'll pair with somebody else, right? And I think that's a very useful way to think about it. You have somebody doing, you can do red-green refactoring. You have somebody writing the test first, and then somebody writing the production code to make that code on the test side work. But even if you don't have another person, and you're a little worried, you can still do it. It just takes a little bit of practice to get into that mindset of just constantly ping-ponging back and forth between between test and production code, okay? So I'm going to open this up, and private string ID, private string name. Now those are the fields, those are the entities, the attributes in the entity that I want to create. And I want a constructor. And I could, of course, do it the old-fashioned way. I could create a constructor the old way, but I'm much too lazy for that. So these days I use Lombok. Lombok's a compile-time annotation processor that'll synthesize a constructor for me based on these attributes. So there we go. My test is passing, so to speak. Well, so for some definition of passing, that is to say, it compiles. Now I want to prove certain things about that object. Did it actually work? Do the fields that I've just created have values, right? I want to prove that that's not null, for example. And I want to say that the name should be equal to something. So I can use these low-level assert methods. These are all very, very low-level. They've been in JUnit forever and a day, right? That's fine. But I quite like the matchers, right? So with the matchers, you can say, OK, matchers dot is equal to, right? Equal to Jane, right? So you get this sort of nice auto-completion about things that you can do that match. Matchers are just objects, right? And if you look at the type, it says new matcher, but don't use matcher, right? This is a little deceptive. You can see that they're trying to communicate with us. They're trying to make us appreciate that this is not the right way to go. So use base matcher, okay? Base matcher, there we are. And a matcher is a very simple thing. It is just a codification of a test that you intend to run more than once, right? So here's a base matcher. Let's see, new base matcher. OK, good. String, sure. And it has two methods. One that runs the test itself against an object or target object called O, and another one that just writes the error to the output. So here you can say append text, oops, error value isn't Jane, okay? This is a very silly test, right? O dot equals Jane, okay? That's way too much work. Normally you would extract out these matchers into a class and then reuse them. The whole point is if you have common conditions that you want to evaluate multiple times in different places that are more complex than a simple, is it null or is it true or that kind of thing, right? You don't have to repeat that recipe over and over. You can extract it out into a matcher, and that now you have this common way of saying, hey, does it match this particular test? For our purposes, yeah, obviously I could have just used the inbuilt matchers, and I probably will. Okay, so equals to, and there's even an equal to ignoring case, Jane. All right, good stuff. So let's see, I wrote 3 tests there. I got ahead of myself, didn't I? I wrote 3 little tests. Normally you should write 1 test and then run the test and then write another test, but I find that takes entirely too long, so I tend to write a few lines, particularly when on stage. Come on, computer. All right, that worked. Surprise, surprise. Now, that's my POJO, that's my thing, but that's not actually an entity. I'm going to persist this to a database, MongoDB. So I'm going to say reservation entity test, okay? And this is going to be a test that just that tests that I've got a valid mapping, right? So I've got an object, but does MongoDB know what to do with that object? That's the question here. And of course, in order to test that, I need to involve MongoDB, don't I? I want MongoDB involved here to make sure that that actually lines up with my expectations. So who knows about MongoDB, right? In this code base? Well, I mean, I didn't mean to involve you, my dear audience. I meant who in this application knows about MongoDB? Well, Spring does, right? Spring knows about MongoDB because I've established a connection factory with Spring. So I guess one way to shortcut all the work and ensure that I have as close a match with the production code would be to instantiate a whole Spring application context. The problem is that Spring is doing a lot of different things for us, right? It's going to create a web server. It's going to create a MongoDB connection factory. It's going to create marshalling and binding. It's going to support an actuator endpoint, maybe, perhaps. You can do all sorts of different things in Spring that go above and beyond what we're trying to do here with MongoDB. So rather than create a whole application context, one common pattern is to create a slice, is to slice out some of the things that are required just to test that in isolation, right? And this is a very common pattern. You'll see code written with a separate configuration class whose whole purpose is to be used in testing only, right? So you might have common beans that are required for MongoDB in a common configuration class, and then you involve only that in your production code, and then you layer that in your test code, and then you layer that in with your production code so that it congeals into one whole thing at runtime for production. That's certainly one option, but the problem is that you end up having to slice your application context layers in terms of your testing, which is, I suppose, not the worst thing in the world, but it is an extra sort of mental step. So we can do it for you. We actually have a thing called a test slice. And what it does is it tells Spring to only instantiate the objects relative to a particular domain or particular tier or particular layer. In this case, we have the data Mongo test. Okay. Now, this is going to be a JUnit class. It's going to be managed by Spring. So I need to tell it to use the Spring runner, and I need to tell it to use the data Mongo test. The data Mongo test is an annotation. You download the source code here. You can see that there's an annotation, and it in turn has other annotations, right? And so that's the way with Spring. We have a lot of transitive annotations, right? We're saying, okay, Spring Boot, don't bother doing auto configuration. That is to say, all your instincts about automatically configuring the web server and all that stuff, ignore all of that. Start up with a clean slate and don't do anything until we tell you otherwise. It goes a step further. We say, okay, but do auto configure the cache and do auto configure MongoDB. Right? So we're bringing in the things that we care about with respect to MongoDB, but nothing else. We also have here a filter, type exclude filter. So here's a data Mongo type exclude filter. This isn't a particularly interesting one. It says, okay, we're going to look for this annotation, and otherwise it doesn't really matter. But we can use these type exclude filters to exclude objects from your application context. So for example, if you're testing the web tier, then you certainly don't want anything to do with the database tier. So you could create a filter that only keeps the REST controllers and only keeps the servlet filters and APIs and the reactive WebFlex router functions and things like that, right? And this way you would only have the web tier components, and we'll see that in a bit, right? These type exclude filters are very handy. They winnow down the sort of aggregate number of beans that are going to be managed by the Spring container when this test runs. So we can focus on the thing under test, which is in this case our ability to talk to a database. So here we go. I want to now talk to a database. So there's a couple ways to do this. I'm going to create a repository, right? So I'm going to say private final, private reservation repository. Okay? Now, of course, I don't have this type, so let's go ahead and create it. Okay, there's this. And this is just an interface, and it's going to be, I'm going to extend the reactive Mongo repository, managing entities of type reservation whose primary key is of type string. This is a repository. It's meant to handle the tedious, soul-annihilatingly boring read, write, update, and persistence lifecycle of data. So all the sort of usual suspects are here: insert, find all, delete, count, all that kind of stuff. If you haven't been hip to the new reactive stuff we're talking about these days, these are publishers. They're meant to describe asynchronous sequences of data. Okay, there's specializations there. We don't need to worry too much about that for now. But suffice it to say, we have a repository now. I'm going to tell Spring to inject that here. In JUnit 4, you need to use @AutoWired on fields, right? Which is makes me want to take a shower. In JUnit 5, however, you can do constructor injection again, which is a-okay. Okay. Now we have this repository. It's going to be instantiated. It's going to be managed by Spring. It'll be swept up and it'll be retained as part of this data Mongo test thing. And we're going to use that to write data to the database. So reservation repository.save, and I'm going to create a reservation object. Okay. I'm going to pass a null for the ID, and there's Jane. Okay. Now, I've got this entity R, and the result of that is actually a publisher. Think of this as like a future. Right? Except that it's a future that doesn't automatically start resolving until you call get. So imagine a future that you have to call .get on. Otherwise, nothing happens. Right? It's a cold stream, very much like the Java 8 Streams API. So in the reactive world, in order to start something resolving, you need to subscribe. Okay? That actually forces it to resolve the data. The problem with that, of course, is that now I'm managing asynchronous callbacks in my test code, and it gets very tedious. It gets very weird. You end up trying to force it to finish before the test finishes, and you get into like countdown latches and cyclic barriers, or worse, thread.sleep, that kind of stuff. So instead of doing that, we have a thing you can use to verify reactive APIs, asynchronous APIs. It's called step verifier. So I'm going to say that I expect it to complete successfully, but before I expect it to complete, I want to expect certain things about the data that's going to come back. This is an asynchronous sequence because it's a mono, it's an asynchronous sequence with at most one value. If you were using a flux, then it could be potentially infinite values. But in this case, it'll only be it'll only ever be one value. So here, it's fair to say that I'm expecting one value, so I'm going to create one expectation. If I had 10 values, I could do this, and I could do expect next count, whatever, right? I could do, if I had, let's say I had 12 values, this would actually match. It would match the last 10, it would match one, and it would match another one here, right? So you get all that. Okay, so I'm going to match this. Now I've got my reservation. I'm going to say, okay, I'm expecting the name to be equal to Jane, and I'm expecting that the ID is not null, right? I could use this, or I could do string utils from Spring. Not that this hasn't been thought of before, but here we are. Okay. So I'm actually telling the thing what I want to do with the entity that comes back. I'm proving that the ID is mapped. And that's important, by the way. Here, by default, Spring Data MongoDB will look for a field called ID, and it'll automatically map the primary key, or the key in the MongoDB document, to this ID field. But what if I called it my key? Right? That wouldn't work anymore. You could override the default by saying @ID. You could signal to MongoDB that this should be the ID. But you want to make sure that that works, right? That's why you write these tests, to make sure that you can round trip an entity, that it can go to the database and come back with a primary key. So run this test. Let's see what we get. Does it work? All right. Seems to have worked. There's our result. No issues. Good. So we've got now an entity and a POJO. What's next? Well, the question then becomes, do I trust this repository? Well, of course I trust it, right? I trust it to do all the things that are implied here, the insert, the save, the find by ID, etc. But you can also write your own custom finder methods, right? You can say find by name. So this will look in MongoDB and find, whoa, easy. This will find all the reservation entities whose name attribute is equal to whatever you pass into that parameter. That is something that you need to test, right? You could override the query by providing a MongoDB BSON query. Or if you're using Spring Data Neo4j, it would be a Cypher graph database query. Or if you're using Spring Data JPA, it would be a JPA-QL query. Or Spring Data JDBC would be a SQL query, right? It would be whatever query you want. But now you've got strings in your code base, right? And these things could change. You might change the schema here without remembering to change it here. So you need to write tests for this code. So it's also very important to remember to write tests for that kind of stuff, right? So you would do that here as well. You'd say test public void find by name. Right? I did the production code first, didn't I? So here we go. We're going to say this.reservation repository find by name Jane. Now, of course, this is the result that I'm expecting, but in order for that to work, I need to have some sample data in the database. So what I want to do is I want to say this.reservation repository.delete all. I'm going to delete everything. Then I'm going to write this data to the database. And then I'm going to search by name. Sorry, I'm going to write data here. I'm going to say reservation repository.save new reservation Jane, pass in null. Okay? And then finally, I'm going to find by name, so Jane. In which case, I don't need that. So that's my new pipeline. That's the thing I want to actually put through the verifier, because the last thing that will happen is I'll get back all the results that match Jane. And I've deleted everything first. I've written one record into the database that should match, and then I get it back. We can actually write two records. Let's just say that we have another record here. Null, John, great, good stuff. Okay, so now I'm just saving all the records. What did I do? Oh, it's got to be a publisher. Okay, so flux.just, good. Okay, so this is my new pipeline. Assign that to a variable. That's my entire pipeline. I'm going to put that into the verifier, reservation flux. I'm going to expect the next count should be 1. Expect next count 1. Verify complete. Okay? That's the entire thing. Okay, I'm now writing another test. Very simple. Hey, didn't run this one, did it? All right, that worked. Even despite myself, it worked. So good, so now we have that. Now, the next logical thing is the web tier. Reservation, HTTP test, all right? I'm going to create an HTTP API. I've got data access, and I could create a service, certainly, and you're more than free to do that, but that would look very similar to what we just did. At this point, I want to test the web tier. So I'm going to create a JUnit test, and I'm going to use the web flux test data test slice, okay? And so this is different from the Mongo test. This is going to instantiate all the components that have to do with the HTTP layer, and not, very importantly, the stuff to do with the data tier. And what that means is that we're going to instantiate the web tier, and the web tier presumably is going to depend on the data tier, and that Spring Applications context is going to spring into life, pardon the pun, and it's going to fail, because there's no data tier there. None of the beans that it's depending on have been registered with the context by design, right? So let's see what that looks like. So in order to write this test, I'm going to inject the web test client. This is a reactive web test client. It's a mock client. It's not going to actually spin up a web server. It could. And it's going to launch HTTP requests. It's going to verify that if you send a request of a given shape into the web server, that you get back a response that you expect. Right? This isn't to verify that Tomcat, or in this case, Netty, can send the right bytes across the network. It's more about, given an HTTP request with the following headers and the following shape, I get a response of the expected shape. Okay? We're not trying to prove that Tomcat works. We know it works. That's not what this is about. Now, I say this.webtestclient.get.uri HTTP localhost 8080/reservations retrieve exchange. I'm sorry. And I'm expecting that the status is going to be OK. I'm expecting the header to have a media type, application JSON, and I'm expecting the body to have a certain shape. And I can poke at that body in a number of different ways, but I find that the most useful way is just to use JSON path. You've presumably heard of XPath. Who here knows about XPath? XPath is a way to query into a document, an XML document. It's a declarative kind of way to say I want to match a particular stanza in this XML document without having to like write the DOM code to do that. Well, JSON path does the same thing here. So I'm saying match, assuming I get an array, this signals in an array, look at the 0th element in the array, get back the name attribute of that element, and assert that that element equals Jane, okay? So that's my web test client. I'm poking at the HTTP tier, and I'm getting back results. Now, the question then, of course, is where does that data come from? Let's try running. Let's run this test, see what happens. Wrong test. All right. A number of different issues. At this point, you can see it failed because there's a 404 not found. We haven't implemented the web tier, right? So let's do that. Reservation, HTTP config. Okay, this is in the production code. It's going to be a Spring Bean that registers objects just registers objects. In this case, I'm going to register a functional reactive endpoint using this new style. You can use REST controllers. That's fine too. It doesn't matter, right? And it's going to return a route. So route.build.get/reservations, new handler function, return server response.ok.body. And what I'm going to do is I'm going to inject here as a collaborating object my reservation repository and return that to that. So here's the find all results. Now, what this does is when somebody goes to /reservations and they issue an HTTP GET request, we'll get back this response, okay, like that. That's our result. It's our functional HTTP endpoint. Now, I want to test just this bit, so I'm going to take that, go back to my reservation HTTP test. I'm going to import that here. .class, all right? Good stuff. So now we can restart. Does that work? Come on, do the thing. Good. So that didn't work. And I think we can imagine why. We don't have a bean. We don't have a bean of type, no qualifying bean of type com example producer reservation repository available. Expected at least one bean available. Well, that's because our webflux test slice excludes everything and only brings in those components that have to do with the web tier. We've established that before. So now the question then becomes, how do I get when I implement this reservation HTTP config endpoint, I inject the reservation repository in service of the HTTP endpoint. But now I've got a Spring application context where there is no reservation repository. I still need the reservation repository. I just don't need it to be like a live fire, actual connected thing talking to MongoDB. We've already proven that MongoDB and all to do with MongoDB works just fine. I don't need to reaffirm that. What I want to do is instead create a mock. I want to mock out that collaborating object, don't I? So I go back to my reservation HTTP test, and I want to mock out the repository. I could create another Spring application configuration class and then selectively re-import that with just the mock and do that kind of stuff if I want. But there's a much easier way. We can say mock bean. Mock bean is like Mockito's mock, except that it also works in conjunction with Spring. So it's going to create a Mockito mock, right? By the way, that's the nice thing about Spring's support for testing. You didn't see me when I was back on the Spring initializer. You didn't see me select a checkbox for test. It's 2019, or indeed it was 2014 when we first added this. We just assume if you're using Spring Boot, you're going to do testing. It's the right thing to do morally, right? And so we just give you that. That transitively brings in things like Mockito and JUnit and all that kind of stuff, right? All these different things that you need, Assert for J, all that kind of stuff. And so we've got Mockito in the class path. Mockbean brings in, it uses Mockito, but it does one extra thing. It takes this parameter, this field, and it says, oh, you're trying to create a Spring bean of type reservation repository. We're going to register this bean in the application context for you. It's going to be a mock bean that we're going to register in the context. If there's already a bean of type reservation repository in your context, this will replace it. If there is no bean, then this will be added. Either way, the result is now, when I inject my reservation repository in my reservation HTTP configuration over here, the thing I'm getting, the collaborating object, is not the actual repository, it's the Mockito mock that I want. Well, I say the word mock because I'm just using the language of Mockito, but I don't really want to mock here, do I? right? Because what is a mock? A mock in testing parlance is it's an empty object. It's a skeletal bucket that returns null, 0, false. It does the minimum possible to fill the shape that you need to have filled, right? It has the shape of a repository, but nothing else. If you poke at it at all, it'll blow up. It doesn't do anything useful, right? What we want is a stub, which is a mock with pre-programmed results. So I am going to stub the behavior here. I'm going to say Makito dot when this dot reservation repository dot find all, then return flux dot just new reservation 1 Jane. Okay, there's the stubbed behavior. I'm telling Makito that when somebody calls dot find all on my mock repository, I expect this pre-programmed result to come back, and that should match this test, right? So let's see if that works. I've imported this, good, right? Let's run this now. Green is gorgeous. Look at that. Our test worked, and because we're only starting the web tier stuff, it only took 177 milliseconds to do the whole thing, right? We're not starting the whole Spring application in context. All right. Now, we have our web tier. We have a data access tier. Let's build a client. Going back to here. And we're going to build a consumer. Okay, and we're going to use everything except the MongoDB support and the verifier. We're going to instead use the stub runner. Okay, I'm going to generate that project. So now, UAO consumer. Okay. Now, same as before, I'll remove Jane at 5 for the moment. I'm going to exclude the exclude. Bring that in. Okay. And all I want to do here is, all I want to do here is I want to make sure that I can build a client that will talk to that HTTP interface. Just a simple client, okay? So it's just one test here. I'll just use this for now. So auto-wired private reservation client. And I'll create that type here. And this client will have a simple job. It'll say, we're going to create a call over the network to get all the reservations from that HTTP endpoint. And a lot of organizations do this. They'll either develop their own client, right? It's useful for the team that builds the API to build a client, but you got to make sure you do the right thing. Don't build in too much business logic in the client, right? It should be freestanding HTTP API. Everybody else should be able to use it too, even if they're not using Java and whatever. Heaven forbid, right? So we're going to build our own client. So what I'm going to do is I'm going to build a client here. I don't have this type on the class path, of course, so I'm going to create that class here. Private string ID, reservation name. Okay, good. So there's my client, and now when I inject that, I want to say that this.client.getAllReservations should return a publisher of reservations. I want to verify that when I call that endpoint, I should get, let's say, one value, okay? Or better yet, let's say I want to get one value after I've gotten the first value. So I'm going to poke at the first value with a predicate here. Predicate, new predicate, reservation, return reservation.getReservation name equals, let's say, Jane, okay? And reservation.get ID should be non-null. All right, so come on. This gets silly at some point. Here, first one, invariably, has text. Okay, so there's that. Good stuff. Now, we are going to run this test. What do you think is going to happen here? Well, I mean, I suppose we shouldn't leave it to our imagination, so let's just run it and see what happens. Didn't return, okay, so that didn't even compile, not a valid test. We want the web client. This is the non-test version of the actual reactive web client. I'm going to inject it through the constructor. I'll just create a required args constructor automatically for any fields that are final. So return this .client.get.uri HTTP localhost 8080/reservations. I'm going to expect the data to come back. I'm going to turn the resulting JSON into a stream of reservations. Now what? Let's see what that happens. What happens now? Okay. Oh, whoops. Wrong JUnit. Make sure you use the right JUnit. Okay, so we can see another problem. This wasn't a valid Spring bean, right? So Spring couldn't have injected it for us, but you can see that here, right? So that's what that error was. Okay, now it still failed, and at this point, I think we can easily guess, the reason, which is I don't have a web client bean, so we can go back to our application here. Good. But web client.builder, return builder.build. Good. And are we now at the place where we can guess it? Yeah, of course. No, there's no response. We got a connection refused. I'm not running the service, am I? Right? Here's where we get into trouble. This is where I think a lot of people get tripped up. I've got a service and I've got a client, and they're talking to each other. I have disconnected the business logic. I've extracted out the business logic from one monolithic application into two small microservices. And now, in order to test the interactions across component boundaries, I need to have both sides of the equation up and running, right? Well, what is the response here? Do I run all my applications on my local machine? This is not a good place to be in. We get into a little bit of trouble here. I don't know what it is like here in beautiful Canada, but where I'm from, back in the States, in San Francisco, in the Yay area, the customs are a little different, right? You can go into a nightclub in sandals and a t-shirt, for example. And it is considered very polite if somebody comes to your office and they start the job with you, they start a new job at your company, it's very polite to say to them, welcome, have a nice, I hope you have a nice day. Here's your chair, here's your seat, here's your laptop. Is there anything we can do for you? That kind of thing. These are all very nice things that you can say to somebody who comes into your organization brand new. It's considered very, very rude on the other hand. It's very hostile, very aggressive. It has caused some people to walk out in disgust when you say something like, welcome, have a nice day, I hope you have a great day, here's your chair, here's your seat, and here's the Kubernetes cluster that you have to deploy just to test our API, right? Nothing is more offensive to somebody than saying, deploy this Kubernetes cluster to test your iPhone app. It's ridiculous. So, is that the solution? Am I going to sit here and deploy a cluster just to be able to get a hopeful end-to-end test of this? And even if I did, am I in a good place if I did that? Wouldn't the result be that now every time I want to test this little tiny test, what used to be a unit test because it was just on the same monolith, it was in the same code base. Now every time I want to do that, I now have to wait for the entire lifecycle of the application to work. Is that a great situation? I mean, sure, it's a lot of people say, oh well, we have the cloud now. I can farm out the work of setting up a cluster, but still, you're waiting for that whole thing to spin up every time, right? And presumably, you're doing a tear down and setup each time. This is a really bad place to be in. So what we want is to mock out, or we want to have the effect of talking to that service without actually having that service. We can actually mock out that service. Okay, so we're going to do that here. I'm going to use wiremock. Anybody here use wiremock before? Okay, so we're going to say auto-configure wiremock. I'm going to run that on port 8080. Wiremock is like a mock for your object, but it's going to mock out the HTTP API. And in order to use that, I'm going to write this code, wiremock.stub for wiremock get wiremock a URL equal to reservations. Okay, and when I create that wiremock, it's going to return a wiremock.response with a body. I'm going to talk about that in a second. With a header, HTTP headers dot content type, and the value will be media type application JSON value, okay? And it's going to produce a response with a status of HTTP status.ok.value, okay? Now, yeah, that's the watermark API. That's not our API. It's their API. This whole thing makes me unhappy. There it is, though, right? I'm going to return a body. Now, I can return a string, I suppose, right? We can do that. So we're expecting two results. What are we expecting? We're expecting some JSON, like that. And we have to do ID, //. Okay. I'm going to put that value in. The first value is going to be Jane, right? That's the one we want. ID will be, and then it'll be like this. So reservation name, and the ID will be 1. Reservation name will be Jane. Okay, that's one record, and we're expecting one more record, aren't we? So we have to copy and paste this. Okay, get rid of that. John. All right, good stuff. So there's my second record. That should work. Let's try that. Okay, that worked. Good stuff. So it's green here, it's green there. We can go to production, right? Well, no, actually. Surely not. Because we've just skipped a very important step. You see, all this time, I've been running this code. I've been using the reservation name attribute on the consumer side. On the producer side, though, there is no such attribute. It's just name. I fat-fingered the attribute. Somebody changed something, and I didn't detect that. I used wiremock to mock out the object, but it's not like a real mock, like a Makino mock, because it's not verified by the compiler. There's nothing here guaranteeing that if somebody changes something on the producer side, it won't break my code on the consumer side. I would have only ever discovered this bug when I moved the code to production, which, unless you're Chuck Norris, is not where you should be doing testing, right? So, what do I do? Am I back to square one? Do I have to redeploy the cluster? I think not. That's not a great place to be. What we want is some way to get the fast feedback loop that we get by doing unit tests and small sort of pseudo integration tests, as we have done so far, without sacrificing the validation of what we're trying to do, right? And so this is where contracts come in. Consumer-driven contracts. How many of you have heard of consumer-driven contracts? Okay, a few of you. So the idea here is what I want to do is I want to verify at test time, not at production, not in runtime, that if I make a request to a given API, I'm going to get a response back. A contract is a test. It's a thing that you say that if you run it against your API, will actually match. Okay? So you use a contract to describe a given interaction with your API. You say, given a request of the following shape to this API, I expect a response of the following shape. And you can use contracts to capture discrepancies across multiple API versions, right? So if you have version 1 of your API and you want to move to version 2, but you want to make sure you don't break anything in version 1, capture that all in contracts, okay? And the benefit of a contract is that it's a shared artifact. The people on the other side of the API boundary can use your contract to stand up a mock HTTP API that looks just like your real API, and it has to match your real API, because remember, we're going to create a test based on that, and it's going to actually talk to your API. So if your API doesn't work, then it won't ever be deployed into production, right? It'll break the build. And once it is green, then that contract will be deployed to a central place, usually your Artifactory or your Nexus or whatever, and then you can use that on the consumer side at test time as well. Okay? So we're going to do that. We have a project called Spring Cloud Contract. Spring Cloud Contract supports DSLs in a number of different languages, including Java, Kotlin, and Groovy. I'm going to go ahead and use it in Groovy. There's a source main resources contracts folder here that was created for us. I'm going to create a new file here called should return all reservations.groovy. And here I'm going to create a new contract .make. Okay? I'm going to describe a request and a response. So the request is going to have a certain shape. I'm going to say the request is going to be to /reservations. The method will be a GET request. And the response that comes back will have a status of 200. It'll have a body. We're going to come back to that in a second. And it'll have some headers, right? A header like this, content type, media type dot application JSON value. Okay. Now this body, I could do a string, right? I could do a multi-line string because it's Kotlin, so sorry, it's Groovy, so it supports that kind of thing. Or I can use this kind of nice syntax in Groovy where I can do like list literals, right? So I can actually look, it looks kind of like JSON, except it's not. So I'm going to say ID is equal to 1, and what is the attribute name? It's called name, and it's going to be Jane, and ID will be 2, and name will be John. Okay, there's the JSON-ish thing that I'm returning back from this endpoint. So this contract is actually configured for me, but this is going to turn into, let's go ahead and run it. You'll see what I mean. I'm going to run this code here. I go here, Maven clean package, or install, I suppose. That's the right version. It's going to fail. And the reason it's going to fail is because it's going to turn at compile time, thanks to the presence of this plugin, the Spring Cloud Contract Maven plugin. It's going to turn this contract into a test. And that test is going to look very similar to the Reservation HTTP test that we created earlier. It's going to poke at our HTTP API. So here you can see find, it failed, right? Find iname, sorry, dot iname, contract verifier test.java. Okay, cat this. And there's a test. It's actually saying, hey, given an HTTP GET request, 2/reservations, expect the status code to be equal to 200, expect the content type to match application JSON, and have a JSON structure that has the following shape. Okay, but it's just a unit test. It's just a JUnit unit test. And of course, in order for it to talk to our API needs to be up and running. Well, we saw how earlier we used the Spring test framework to sort of create the mock HTTP API, right? To stand up the API and make it available. We did that by using Webflux test and by doing import this and all that kind of stuff. So we need to do the same thing again in a base class. We need to provide a base class that our test can extend from. And we also need to provide a collaborating object, right? We're going to have the same issue as before. We need to do this as well. We need to provide a reservation repository. So we're going to create a base class here. Base class. And this class is going to be it's going to have a before method, set up. Okay. And it's going to have a few things to it, right? So we're going to say, first of all, mock bean. Actually, I can copy and paste that, can't I? I can copy and paste a few things here. Okay. Good. So we don't need this. Whoops, we do need part of that though. So we don't need that. This is before. And we don't need this thing anymore. We want that, okay? The other thing we need to do is we need to tell it where to find our API. So we're going to say, yes, I want to run with Spring runner .class. I might as well use the Spring Boot test. It doesn't matter in this case. I'm going to provide certain properties. Okay, server.port is going to be 0. There's different ways to do this, right? It'll be a random port. But now we're going to start up the web server on a random port. We need to tell our framework, our Spring Cloud Contract test, where to find that port. So we're going to say local server port, private int port, and we're going to use that here. We'll say rest assured base URI equals HTTP localhost this.port. Okay, there you are. That's the base URL. So now it's going to run that, and it'll talk to that. So do we have anything else we need to do there? I think that should work. Let's see if that works. Okay. Fingers crossed. Awkward. Illegal state. Oh, we forgot to tell Spring Cloud Contract what base class to use. So we created the base class. You have to go to the build. Now this is a contract. Remember, something is enforcing that this happens. That's the nature of this plugin here that we've got already configured for us. So base class for tests, it's going to be com example producer base class. And you can do all sorts of different mappings. You can have different base classes for different tests based on patterns and so on. Also the test mode should be explicit since it's a reactive API. Okay. Take 2. Fingers and eyes crossed. Okay, so we have, did I give it, look at that, I gave it too much data. I think I did something wrong with the data, the contract there. So it's getting a lot further along. We have a body. And what am I saying? In the contract, here's my contract. I'm expecting 2 results back. In the base class, I don't return 2 results, though, do I? I return 1. So I go to my Mockito code and return a new reservation to John. Okay? Take 2, or 3, I suppose. All right, good. So it's green. We installed it, and when we installed it, it gave us the usual suspects, a jar. It gave us our POM, but it also gave us the stubs jar. And the stubs jar contains a WireMac definition, a textual definition that WireMac knows how to read. So we've installed that into our Artifactory. Now imagine you're doing continuous delivery. You're on the producer side, change, git commit, git push. It goes into your continuous integration environment. It goes green. You run this test. You do a Maven deploy. Right? It gets deployed to Artifactory. And of course, you're doing continuous delivery, so you've also deployed into production. You've deployed your apps to Kubernetes, you've done blue-green deploys or Cloud Foundry or whatever, and now you've got your app up and running. Now, the Artifactory definition of your contract matches the production definition. Now, on the client side, I want to use that definition to make it easier to ascertain that this is all working, and I want to sidestep all that nonsense, right? And so I can say, instead of using WireMock, I'll use the stub runner, okay? And all I need to do is give it a definition to the Maven artifact. I'm going to say find the group ID called ComExample, artifact ID producer, find the latest version, and then run the resulting thing on port 8080. The other thing I want to do is I want to tell it where to find that stub. So it's going to find the stub either on this consumer jar's local class path, or in my local Maven repository, or a remote Maven repository. I'm going to tell it to look locally. So what this is going to do is at test time, this code in Java is going to actually run the Maven resolver. It's going to resolve this artifact looking in either your local repository, local class path, or your remote run, okay? But otherwise, it's going to download this from, so again, I could have the producer on some other machine. Just because I installed it in my local one, it could be downloaded from another one if I wanted to. Now we run this again. I've commented out the WireMock stuff because I don't need that. And we're so close. You can see we got a bug. See? We're getting back, the data that we're getting back is named name, right? And if you look at the error here, it says we got a null pointer exception for reservation name equals null. We caught the bug. There's a bug, there's an inconsistency in our local API versus the remote one. Easy fix, go back to this, change it. Where else did I use that? Build this. Okay. Okay, clearly there's a problem. Name, run that. All right, we're green. So with contracts, we're able to write code that actually captures how we expect people to interact with our service. We're able to produce a very, very cheap, lightweight definition of that API that looks exactly like the API that we're actually shipping in production without having to stand up our database or our message queues and our Kubernetes cluster and all that stuff, right? We don't have to run that. And there, by the way, there is an alternative to this, I should mention. Apple just released a Slack runner. Right? Have you seen that they announced a Mac Pro with 1.5 terabytes of RAM? As far as I understand it, that's enough to be able to run both Slack and Kubernetes at the same time. Right? That's a new thing. So maybe all this will be obsolete in a few years. Who knows? We'll all have Mac Pros with 1.5 terabytes of RAM. But in the meantime, this should allow you to go to production and get testing, get iterative without losing the flow, without falling out of flow much more productively. Now, of course, you might be saying, I'm using Java and I'm using Spring here, but what about those poor sops who are using some other technology that doesn't have Spring there, right? Like JavaScript or something like that, right? Well, in this case, we have a jar you can download. It's called the Spring Boot Test Stub Runner. There you go, Spring Boot Stub Runner. It's a jar. It's a standalone little jar. It's a few megabytes. You give that to somebody, and they can provide a command line argument. They just do java -jar, provide the command argument, give them this exact string, and it'll actually download the contract just like I did in my test here, and spin up a Watermark API and leave it running. So now you can go to localhost 8080 in your browser, /reservations, and you'll get the pre-programmed result that we saw that was defined in that contract. Now, if they want to test their iOS app, they can test it against a thing that looks exactly like the production API that's defined or informed by this contract, right? And if we change the contract, that string will pull down the latest one, and they'll get the new one. They don't have to redeploy their cluster. All right, my friends, I hope you got something out of this. I have talked about HTTP here today. Obviously, APIs aren't only HTTP. We also support messaging. So if you're doing Kafka or RabbitMQ or whatever, we support mocking out, specifying a contract for asynchronous reception of events or messages, right? That's a natural thing to do here. There's a lot more we could do with Spring Cloud Contract. You can also support packed definitions. So if you've ever heard of packed, that's another way of doing consumer-driven contracts. I hope you got something out of this. Who learned something new? I'm just curious. Anybody learned something new? Thank you so much for sticking around. I appreciate it, especially in light of that jaw-droppingly gorgeous backdrop there. So I'm happy to answer questions, but otherwise I appreciate you hanging out, and have a good lunch, and I'll be around. Cheers.